Man. All right. So let
Write
me
that
just
down.
wade into this. So for anybody in the audience out here, uh, it's my job to tell you that this is really hard because I've spent a lot of time in the Andrena to discover life key and now more and more in the primary literature. And I start out believing that I'm just not good at this, but then I entertain the possibility that anybody's going to find this really hard to do, uh, often in the absence of images. So I make these images partly for the betterment of the entire world, but mainly so I can figure stuff out. So if I walk through this a little bit, this document.
Can you make it full screen, David?
Yeah.
Thanks.
This document is what I want to tell myself about how to really understand this stuff. And I'm wide open to anyone's telling me how to make this a little more clear and what features I should add. But if we start here, the vertex seems to be an important thing. If you look at the top of the head of an Andrena, for me, it's a little hard to get a handle on, like, you fix in your mind what one ocellar diameter is, and then you try to imagine how far away that is from the edge. If you use a reticle, it's a mess because it's a very small structure and you're, shaking around and so on. So for me, this sort of helps. Okay, I got a sight picture of what one ocellar diameter looks like. And when I'm really lucky, I get something that's so clearly much more than one, and that becomes a good character. A lot of times it's intermediate, and then you have to go to other characters. This one is straightforward. You just measure the pieces of the antenna. Fovea are.
David,
Go ahead. Of course.
Another thing to think about on the ocellar diameter is that in Discover Life, it's not a one answer thing. So when we score things, what we try to do, and this is pretty good for the East, less so for the West, since we only did that once very quickly at Logan, is if there's any ambiguity, we'll score it for the diameter classes that are on either side.
Right.
So that's our optimal choice. And so that's something to think about. So if you have a question like, oh my gosh, is it one or less than one, which happens all the time, click both.
Right. And of course, we've talked about this before. There's a trade-off then. So you're being conservative in giving a broader range, but it also makes that character less useful in constraining what my choices might be. And that's just the eternal, challenge of doing a key like this.
But I'll point out that if you did if you chose conservatively and you ended up an answer, your confidence would probably be higher on the answer.
Right. And with an interactive key, you've got so many different lines of evidence that you're a little bit protected from that. I have a number of pictures of fovea. Fovea are really tough. You have to have the light correct to see them. For a while, I wasn't sure what's light and dark because sometimes dark hairs look kind of light depending on what the how you're illuminating it. So color, width of them. Again, for me, the little arrows in this picture of a fovea that's wider than the antennal base, I kind of have to put those little arrows on to give myself a sight picture of, okay, that's equal more or less, these two things, versus I think I have one where in this one, the antennal diameter is clearly greater than that of the fovea. Another one that's a huge problem for me is like depth of fovea. Like, how do you figure that out, right? And again, it's a lighting question to some extent, but I find myself like really excited when I find a specimen where I can say, oh yeah, I know that's deep, right? So it's a very clear thing. And until you've looked at a bunch of these and compare one specimen to another, the relative deep, not deep thing is hard to figure out. And I don't want to necessarily walk through details on these because I think it's more helpful right now for Mike to to give his wisdom on all this. One other thing to mention here is Mailer space. Mailer space is really hard if you haven't looked at a whole bunch of specimens to understand like what are they talking about? If you look at these structures, there's this space, there's this big wide space, there's this little, bulbish thing. Is that part of it? And so it's easy to confuse yourself until, for me, you put these things side by side and you say, especially this one I'm looking at right here, oh man, that Mailer space is very long compared to this one where I have a little yellow bracket showing that it's much shorter in this dimension than it is wide. So, that's what I'm after. Another thing that's tricky is when you talk about the labral process. Entire is fine. Here is one where it just smoothly rounds at the terminus. Here's a really cool one when you see it, this strap-like labral process of Barbalabris. That's probably a character that by itself really narrows you to that one species. But otherwise, you're looking at emarginate. There's a little, indentation here. Bigger indentation, is this emarginate or is it all the way to being bidentate? And, I can't always say for sure, but it helps me to look at a range of pictures and get a sense of what those terms might be describing. And then I'm going to just stop with this final character because I'm sure Mike is going to hit this. But for the novice, which I consider myself still to be, looking at the pronotum is challenging. One, because on most specimens, it's going to be obscured to some extent by the head or by the hairs or whatever. So it's hard to get a clear sight picture on it. But when you do, you have to try to decide what the shape of this margin of the pronotum is. Is it a sharp angle or is it a smooth curve? And I have to stare at this for a long time before I get a really clear sense of this. So these pictures help me. And then there are these interesting other features besides the humeral angle, which with a posterior edge of this. Then you have these sort of ridges that might run through the pronotum. And then even more interesting, you have this diagonal suture. That's another important feature I know in subgenus keys. So anyway, I don't want to, belabor all of this, but this, for me, it's really helpful to get really clear pictures. And a lot of these pictures I put into Discover Life key, but I love to look at them really big and also to add a little bit of verbiage so I can, offer a plain English language description of what I have found useful for these. So that's my intro to all this. I'd say we should move back to Mike.
So let me just say, David, I have never seen these things explained so well with pictures that are illuminating. These are really difficult shots to get for most people, particularly the pronotal areas and things. Is
yeah,
a nightmare. So thank you very much. And also, you can answer offline or something. But is this ready to have to be linked to? And
absolutely, yeah.
Okay, well, if so, can you put that out to the bee monitoring listserv? I mean, you did it. You should be out there chatting.
Sure,
Could you do that?
Sure. No,
okay.
I would love to. And I really want to improve this with anybody else's feedback. And if, because I'm deep into this, if someone says, can you please photograph X, Y, if I have a specimen that exhibits it, I'll shoot it.
Yeah.
And luckily, you guys out there have sent me enough spare specimens that I can break their heads off, which is really helpful.
Yeah. The last thing I'll say, and then we can pour it over to Mike, is that, learning to learn your whatever the bees are, making a guide, even your own, where you just grab pictures or, just screenshots and make your own notes, that really is useful. All three of us do that. And I think we've really become better for the process of having to create a guides ourselves. So it's something that I think anyone can do, even if it's just notes to yourself, and that will, in a way, be a good study. You'll learn. It'll fix in your mind better. Okay, Mike.
Okay.
Okay. So people that have been studying Andrena for over 100 years have always done it subgenus by subgenus. It's one of those huge groups, and the subgenera concept helps divide these hundreds of species up into manageable units. So it has a long history of subgeneric study and publications. And one of the things about Discover Life is at the very bottom of that introductory Andrena page, you have the option of clicking on a subgenus if you know what it is, which greatly simplifies things. So that's why I have this key to the subgenera in the East, in the Greater Midwest, because it's a helpful thing. It eliminates a lot of headaches. And the very first thing, at least from my perspective, that helps break everything into two big chunks is what David just finished with. It's the pronotal features. And this works for both males and females.
I'm going to share my screen for you, Mike, and so
Okay.
I'll bring your guide up, okay?
Oh, okay.
And then, so there we are. I'm going to make it zoom in, and then people should also, and write notes on this in your documents that you have from Clare. Zoom 150, why not? Oh, maybe it was. Let's go a little bit more. How about 200? Okay, all right. And you go right ahead. Oh, can people see it?
I can.
Yeah, it looks okay.
All right, good.
So David described the pronotum succinctly, and there's more than one feature of it that's important. And there's what he called the humeral angle, or the that corner, so to speak, the back corner, and its shape, which can be very sharp, like a right angle, and then it can go all the way down to a nice, smooth, gentle curve. So that's important to look at. And also is what we call the dorsiventral ridge, which extends down vertically from that, more or less, from that humeral angle. And it varies from very obvious and dramatic to very, very subtle. And David mentioned this too, which is hugely important. The more representatives you see in Andrena, the easier these features come to you to understand, because they are so variable. So for those in that first couplet, if the pronotum has a ridge extending down from the humeral angle, or if it doesn't, that breaks that whole genus Andrena into two big chunks. And it's very convenient to use that. So that's why I kind of started off with it. But there are cases where you and I would probably say, well, is that a dorsiventral ridge or isn't it? So there are some iffy subgenera, and those come out again later in the key. So that kind of covers the bases if you're not sure. So if that ridge isn't present, there are a few instances where there still is a humeral angle, and that comes out later in the key too. But the dorsiventral ridge is an obvious feature if the head isn't smashed up against the pronotum. That can be a problem. But usually, if you maybe scrape some hairs away, you kind of get an idea if there's a ridge or not. Lighting is everything. If you don't think you see it, move the specimen in many different angles until you really are convinced that either it's there or it isn't, and then move down to the next couplet. So the rest of this key is strictly for females, but I just want to emphasize that pronotal feature is for both sexes. So the male key, which we won't get into today, also starts the same way. So it's a useful feature for both sexes.
So Sam, you highlighted there carinite or not. Is that because you wanted to indicate something?
Well, I think maybe, Mike, if you could go back and,
Sure.
because this is a tricky little phrase. So why don't you explain that one, I think, to folks.
Yeah, a carina is a sharp edge, basically, and or an edge, maybe not necessarily sharp, but usually. But sometimes the ridge, this dorsiventral ridge on the pronotum, it's a ridge, but it's more of a rounded ridge. So you've got, at one extreme, you've got a very sharp, pronounced edge, and that's pretty obvious in almost any lighting. Then at the other extreme is a ridge that's it's subtle, but it's there, but it's not marked by a strong central ridge. And then there's things in between. So just because you don't see a carina doesn't mean the ridge isn't there. And
so it's really a departure from the normal smooth plane. If it bulges out,
yep,
that counts.
yes, yeah, and many of them are just simply that. It's a bulge or a kind of an uprising in the pronotum, and some of those are easy to miss. It took me a long time to really get a handle on that.
Yeah, like Banksy and Cressonii are good examples of subtle.
Yeah, yep. So if you're convinced that you've got a ridge of one kind or another, then the next step is moving down and starting to look at other features. And again, from now on, it's all about the females. So that we're not going to be talking about the males, it's just strictly the females. So this next subgenera or subgenus, Archiandrena, is an unusual one. Most of us probably never see them. And one of the unusual things about this subgenus is that the F1, the first flagellar segment, is really short. And once you see enough other Andrena females, that's very unusual. Most of them have a much longer F1. So,
question real quick from the chat to
yep.
interrupt with, is the dorsoventral ridge the same as the pronotal ridge? As we have some.
Yes, in general, but that brings up a very good point. That sometimes we use different phrases or words for the same structure, and not intentionally, but I mean historically, different terms have been used for the same thing. And Claire, you just brought up a good instance of it. But generally speaking, I think most of the later Andrena work in the last 2 or 3, 4 decades has emphasized the dorsal ventral ridge, and then what that indicates is dorsal to ventral. There's a ridge that runs basically perpendicular or vertical. I don't know if that helps.
Vertical to sometimes at a slight angle.
Slight angle.
Yeah.
It's true.
Yep.
Yeah, depending on your viewing.
It really is a very varied structure.
Yeah, it's fascinating actually, and David pointed out one of the maybe most dramatic aspects of it, which we'll get to here shortly, is in a certain group of Andrena, there's a sulcus or a division or a groove that gets involved in this, that kind of crosses the ridge or stops the ridge. We'll get to that shortly. So anyway, Archiandrena is a really small group, only a couple species, and we really don't know much about them. I mean, I don't know. The nests have never been found, I don't think, and they're unusual. You'd know they're an Andrena, but the F1 being super short is very, very unusual.
I'll mention that I recently saw Mendica. I'd never seen them before in a whole bunch of canopy traps from Georgia. So there were a bunch, and so. And if you look at collections, there are almost none of these of that species have been found recently.
Super rare.
The total numbers are really rare too. So something to think about.
So the second part of couplet 2, which is in smaller font, and I didn't see it here for a minute, F1 is in all the other Andrenas, F1 is almost always as long or longer than F2 plus F3. And it's not short, and that's pretty easy to see. David had a good image of that. So then couplet 3 gets into another pronotal feature that, again, David had a good shot of. This is where the dorsoventral ridge of the pronotum gets crossed or bisected or interrupted by basically a groove. It's a deep, narrow sulcus. It's something, it's not hard to miss if your lighting is good and you can see the pronotum. And that is unique to this subgenus Tylandrena, which now, because time marches on, Tylandrena has been merged with Melandrena. So there are three, in the east, there are three species of Andrena that have this groove or this sulcus that's involved with the dorsiventral ridge. And it's Erythrogaster and Perplexa are the real obvious ones. Then there's another one, Wilmotide, that's not quite as obvious, but it's considered part. And these are all big bees. These are 12, 13, 14 millimeter Andrenas. They're big. And so historically, they're all called Tylandrena, but now that's been merged with Melandrena. But if you, in all the literature, Tylandrena is still historically the subgenus that you would, if you're into the primary literature, you look for. So all the other Andrenas that have a ridge, a dorsiventral ridge, don't have this ridge interrupted or bisected or with a groove that cuts through it or terminates in it. So that's a really unique feature. And these are common, fairly common bees, at least in the Midwest. And all spring species. And I don't know how common they are out east, but here they're pretty common. So the other thing, in the second part of couplet 3, pygidial plate, which you all know what that is in the females. It's this nice, basically triangular, more or less, very usually hairless structure, terminates the T6, the sixth tertum. Sometimes covered with soil or dirt because they use it in nesting, but it's very variable in its shape, its size, whether it's got an internal triangle. It's a very useful feature in many respects, but again, often T6 is hidden or not fully exposed unless you, during your pinning or afterwards, somehow expose it. So sometimes, I mean, you can't see it, but if you can, it can be a very useful feature. And all female Andrena have one. And some of the males have a semblance of one. So it can be really super useful. So the next group is another pretty straightforward one. And
backtrack just a second. So you said the Tylandrena have this, but now is it only a couple of species of Melandrena, or has it like been a full split? What happened there?
Yeah, Thailand. Yeah.
That didn't seem right. I'm confused.
Yeah. Well, yeah. There's still an ongoing folks that are basically reevaluating Andrena subgenera with molecular information as well as different morphological stuff. And so one of the first changes is Tylandrena now is not Tylandrena. These species are merged with Melandrena, which makes Melandrena a bigger group. That's just the way. Go ahead, Sam.
Did they publish that? That was on the
Yes.
video thing that we saw, but is that now published?
It is. Yeah.
Okay.
Yeah.
And how many other, because when I saw their presentation, they were, let's say, messing around with a whole bunch of subgenera.
Yeah.
How far did they go?
Well, Iomelissa, which I don't know if we'll get to late today, but Iomelissa is a traditional subgenus within Andrena on both sides of the Atlantic, and it has gotten merged, or many of its elements have gotten merged with, and I hate to even say this, not this Tylandrena, but there's another PTI Tylandrena.
Yeah.
And I'm not trying to, I'm sorry, this is just the way it is. So we probably won't get to that today, but yeah. And those are the two that I can remember.
Right. So I think we're in for it. And, there's going to be more of these kinds of things. If I remember, they're like, well, several of these species are in different subgenera and actually should not be blah, blah, blah. So I think what we might end up having to do is like, okay, here is the old classification. And again, it's still useful to get to a species, and because the literature is basically based on this, that's good. And then we will have, like in Discover Life, we could have each species can be the old classification, then we can show in another couplet the new classification, and then you're on your own. You know what I mean? So here, maybe we should list this, and then David, you're going to have to figure it out too. That this now reflects, since it's been published, right? This reflects the old classification scheme.
Yeah, actually, Sam, I've put it in the chat, but what I'm hoping is that this current scheme is going to be valid for years to come, because morphologically it works, but in terms of the phylogenetics, it doesn't work. Are we going to have somebody blow all this up in the next year or two and have to start from scratch?
Well, the names, so Mike can say what he thinks here, but my impression is that a lot of the species that are classified using this scheme right now, thank you, Wally LaBerge, for North America, are going to move around. Like, Perplexa is one thing now in the old scheme, but is going to be Melandrena later. So that's why I'm saying that for a while, we'll have to acknowledge or just say, what scheme are you using here? And in this case, it's the old scheme, and almost everyone's doing that. But then I think the new scheme, let's call it, is going to be unsettled for quite a while, because they can't get their hands on every single freaking species. There's 500, right? So I think we'll be using the old scheme for quite some time, but we need to let people know that the subgenus characterization for any individual species needs to be is changing, but this will get you to, in the guides, will get you to an answer of what the species is, which is sort of the point, right?
Yeah, totally. Yeah, the historical documents will not go away. I mean, they're always going to be there. Those names will always be there. And I think I agree. It's useful if you want to identify a species, and that's, again, what we manage, species and populations, not subgenera. So that's what you really want to know. And in a way, it doesn't matter how you get there, as long as you get there. And if you use multiple sources, that's great. But these names are always going to be around.
So one last point would be that just because the DNA people are moving species around doesn't mean that the new groupings, let's call them, of subgenera, and maybe even entirely new subgenera, are going to be easy to key out to subgenus, right? These were based on morphology primarily, so it works. Even though it's tricky, it's a morphologically based one. They're talking about a molecularly based one, and we will wait and see, but you may not be able to get a very coherent morphological, because that's what we're going to look at. We're not looking at their DNA. We're looking at things under the microscope. But so I'm just warning people that just because they move things around doesn't mean it's going to make it easier to ID. It's probably the opposite, and making this relevant for, way into the future, I would think.
Agreed.
All around agree.
Yeah, it's just the way science works.
Great.
So couplet 4 is another very straightforward one. Does the bee have 2 submarginal cells or 3? And that's pretty straightforward. And most Andrena, males and females, have 3 submarginal cells. There are a couple that have 2, and it's usually it's obvious. It's not like, is that 2 or is it 3? It's one or the other. And in the East, it's very simple, because it's just this one group, Parandrena, and these are willow specialists in the East. And if they're collecting from willows, you're probably likely to run into one of them anyway. Off the top of my head, I think there are 3, at least in the Midwest. And they're medium-sized Andrenas. They do have the dorsiventral ridge, but they've got 2 submarginal cells. So if you see an Andrena in the east, with the dorsoventral ridge and 2 submarginal cells, it's Parandrena, period.
Let's also just point out 2 submarginal cells on both wings.
Right, good point. Good point.
Yeah.
Yeah, you always should look at both. It's true. And weird things happen. I mean, it's sometimes they're the wings. We saw a Sevaster atropes, the last workshop we did in January, that had 4 submarginal cells in both wings. I've never seen that.
That's weird.
It was very weird, and it was symmetric. It was perfect. Each wing was carbon copy of the other.
Nagain's wondering if people ever misidentify Parandrena as not an Andrena because of the 2 submarginal cells, or would it not key out to anything else anyway?
Well, I guess probably depends on what key you're using. I guess if you know, all the megachilids have 2 submarginal cells, and there's certain other species and other groups that have 2. I would think, you know, if you know Andrena at all, I think it'd be pretty obvious. You know, the facial fovea are there in the females, and you won't see that in any of the other groups. So I think it'd be pretty obvious.
Yeah.
And Bonnie's wondering if in the Pacific Northwest, if there are any other subgeneras with 2 submarginal cells.
Yes, things are different on the other side in the West. I mean, a lot of these subgenera co-occur. They're you know, they have dozens of species throughout the North American continent. And
out west, one of those is Diandrena. We'll have
right. Yep. And there are Parandrena too out west. So, and my knowledge of the Pacific Northwest Andrena is not very good. So Parandrena in the east, 2 submarginal cells, dorsoventral ridge, in both sexes, in this case. Then there's another strange one, very unique one, which used to be in a separate genus called Iomelissa. Now it's a subgenus of Andrena, but there's only, at the moment, there's only 1 species in that subgenus, and that's Andrena violae. And it stands apart in the east because it has a very long tongue. And by then I mean very long tongue relative to all other Andrenas in the east, which usually have little paintbrush type tongue. But Andrena violae has a thread-like tongue. I mean, it's quite long. I mean, you can't miss it. Sometimes it is. Are we
like thinking like melatoma long, or
not quite that long, but it's shaped that way, and it's long and thread-like, and it's probably 10 or 12 times as long as broad. I mean, but the issue is that it gets tucked under the head, and sometimes, and it's not always. In fact, I'd say most often. You know, not. It's not always recognizable as such. But there's another thing about that species, Andrena violae. It's the clypeus is just inflated is the only word I can think of. It's very, very bulbous, kind of like an anthophora in side view and lateral view. That clypeus is just bulbous, and unlike any of the other Andrena that we have in the east, very, very distinctive. So if you can't see the tongue, you will see the clypeus, and it's pretty dramatic. I mean, that's my perspective, and so that's a pretty obvious one. And I used to think violae was very rare because I hardly ever found it. But then we all started putting out blue bowls, and it kind of shows up everywhere. And it flies. The females fly very low to the ground because violets grow low to the ground, and in a very erratic way. And once I learned that, you can't see them in the field and observe them and collect them. It just took me some time to learn it. So the next option then, if everything, all the other Andrena females in these have the tongue, the glossa is very short, and you would never confuse it with violae. And the clypeus is, while not always flat, it's very weakly convex or inflated compared to violae.
Molly wants to know if we know the preferred violet species for that Andrena.
Sam can speak to this too. I almost always find them at the blue lavender type violet, like Sororia or some of the others.
Yep.
I've never found them at yellow, which always kind of interests me.
Yeah. So, and also that's a very common sort of weed invader if you don't treat your lawn. So if you got a half shady lawn or just almost anywhere, and they'll be in yards. So it's out here, it's a really common species.
Yep.
And when we've done a couple sort of very extensive bowl color trials, and Mike's right, they only end up in blue bowls. And almost all the other Andrena are in yellow bowls, and a few in white. But it's really, really they're doing something really different.
Yeah.
Yeah.
So
I don't know that anyone. It would be interesting to look at that life history, right? Why that big? Why all these features? And what is it about getting something out of violets? Like you just don't see that many things go to violets to begin with, but there it is.
Yeah, they're in multiple. They're in, at least out here. They're in prairie remnants. They're in wetlands. They're in forests, and they're in yards. So it's one of those Andrena species that occurs in multiple habitats, as do violets. So that's kind of interesting as well. Nests, nests have never been found, as far as I know. So that might be kind of interesting to. If you get lucky enough to find a nest, it might be very interesting to see how that nest is managed. Okay, so far you've seen with this group of Andrena with the dorsiventral ridge, these are fairly distinct subgenera and fairly small. It's not like any of these subgenera have dozens of species. And the next one's a similar case. This couplet 6 is Andrena miserabilis in the subgenus Larandrena, which again, in traditional subgeneric literature, there's only one species of Larandrena, and that's this, miserabilis. If you look at the maps, though, miserabilis occurs throughout the country, and there is one subgenus or one subspecies in Florida. So this may be one of those species that's actually a complex of species. I don't know that anybody's looked into it seriously, but when you see a species that's widespread across the whole continent, I mean, you got to wonder sometimes if we just aren't looking hard enough. But anyway, miserabilis females are very distinctive. The clypeus is at least in its central third and sometimes more, is just brilliantly shiny without any punctures and without any microsculpture. It's just this very mirror-like shining clypeus that's weakly convex. And there is no malar space. Remember, David had some good images of that. So the malar space, there's just nothing there. The mandible and the eye are pretty much in contact. The tergites don't have many punctures at all under most, except super high magnification. They're shiny, and what we didn't talk about this yet, and this is another very largely specialized feature of Andrena, the propodial scopa. Now, some other bees have it, and this is a pollen collecting structure of hairs on the sides of the propodium. And in some Andrena, it's just this elaborate structure composed of hairs. It's really pretty dramatic. But they use it to carry pollen, obviously. And so it's a very useful feature, and it has, arguably, it's maybe the most variable feature of all female Andrenas. I mean, it goes from, in one case, like a total basket, and the other extreme is it's hardly there at all. So, and then there's everything in between. So the propodial scopa is incredibly variable, incredibly useful structure. And of course, sometimes it's loaded with pollen, and you have trouble distinguishing some of the features about the propodial scopa. But usually you can flick off, if that pollen is in there, you can usually flick off enough of it to get an idea. So the protodeoscope, I don't know if David, if you have pictures of images.
Yeah,
of
I was gonna say, before we go too much further, can we flip over to Dave's? Like maybe Sam can just do that.
Yeah, that would be
control of the screen. I know that you have
want-
pictures in there of the curricula, and then so I have two questions in the chat. Yeah, can you do it? Since, or I mean, I can.
David, or can David? Because he knows how to do it now.
Well, yeah, just as so long as it goes up.
I can try. Let's see. Can I repeat
one try?
If someone else can do it,
that,
I got it.
okay.
Yeah, do it.
Tim's also wondering where we can find information on the subspecies from Florida. I think he's referring to miserabilis. And then we're going to talk about Mallory spaces.
Mitchell mentions it. In Mitchell's volume 1, he mentions that subspecies. And they're fairly, I mean, I've collected them down there, and they do look a little different. And it wouldn't be unusual out of the ordinary for that thing to really be a separate species. I don't know. I'm not saying it is, but
there you go.
I'll make a comment here on
okay.
them, which is most of the time, much of the time, it's super clear because of all this big, shiny, dome-like, very few pits. It's just unusual. And then there's these ones where it's a big, it's more like a big central bare stripe that's much wider than normal, but not the same. And this may be where we're getting into the subspecies or something else. And a little thing that's been helpful and like, am I missing something here? Because it's pretty extremely different. All the other characters are the same, but a slightly unusual thing for miserabilis is that the scopal hairs on the hind legs are branched but not plumose. So in other words, it's not in the center of the tibia. You have long hairs. First glance, they all look simple, but when you dial in there, you see that they're actually 3 or 4 branches and they're pretty long. And that's been several times helpful in the dealing with the miserabilis that I'm like, is it? I'm not sure. So that's my 2 cents.
Yeah, it's a group that needs some serious work, I think. I bet there might be some things hiding in there. Okay, David's got up on the screen, or Claire has, you're looking at an Andrena female in lateral view, and within that circle, that yellow circle, is the propodial or propodial corbicula, or scopa, however you want to think of it. And this is a case where it's loaded with pollen. And if that pollen were removed or not there, then you would see the internal component, the internal part of that corbicula. And excellent. And in some species, that internal part is utterly bare, no hairs at all. And in this case, it's almost like a perfect basket. And in other cases, there are a bunch of internal hairs. Sometimes those hairs are plumose, sometimes they're simple, sometimes they're short, sometimes they're few, sometimes they're many. So the internal nature of the propodial corbicula is important too. And the surroundings, that beautiful basket-like structure, that's a case of what we call the propodial corbicula is complete or entire, and that it's all there. It's just a complete encircled a group of plumose hairs. Gorgeous. And there are very few Andrena females that have or groups that have the propodial corbicula that entire, that complete, and with no internal hairs. And that we'll talk about that later. But that's a hugely important structure for Andrena. I mean, you can't, no matter what key you use, invariably you have to look at that, it seems like. So those are excellent photos. So it's basically under the hind wing and on the sides of the propodium. They don't always look as nice as that one. Sometimes they're more incomplete. There might not be there might be no fringe on the front part.
Yeah, I was gonna say, can you talk about like where the fringe might be? Because it looks like here with the incomplete one, it's
yeah, that's a good one, David. That could be because what you see on the one.
This one's incomplete here,
yes,
right?
Right. Yeah. And there is no You see the fringe on top and at the back, but in the front part, alongside where you'd see the margin, the posterior margin of the or the metaflora, there's no fringe of hairs, so it's incomplete, and it looks like there's some internal hairs in there. I can't tell for sure. So
Yes,
those are two big differences: complete the images on top, and incomplete below.
And complete refers to just that the fringe is all the way around,
Yep.
or
yep.
is it the drama of this fringe? How plumose, how curvy, like, is that like, because this looks shorter, but is that just virtue of a photograph?
It may be this is the classic complete proportion. Yeah. I mean, the hairs go from front to back. Yeah. All around. Yep. And so those are kind of two extremes. And there are a few species where the Cropodicorbicula is it's essentially gone. There are hairs there, but they're not modified hairs the way the ones you're looking at are. And there are a couple, we can talk about those down the road. So that's a hugely important structure.
Great. And so Mike asked, complete means 360 degrees around.
Or all close to it, 320,
And I went always confused about the measurement of Mallar space, where it starts and where it ends. So while we have I's question up here and the screen, I'm going to find the Mallar spaces, which maybe were up higher.
Up higher.
Here we go.
Yeah, so the Mallar space above and below, easy, because it's between the end of the eye, the lower margin of the eye, which is easy to see, and then the base, the flex point of the mandible. And if there's a space between those two, that's the Mallar space. The difficulty becomes, of course, laterally, because there's no clear demarcation laterally. There is ventrally and dorsally. You've got the edge of the eye and the base of the mandible. But the trick comes, where are the lateral margins? And I just use it usually pretty much, and it's an imaginary thing, but you just have to follow those margins of the eye down and imagine that those are continuous.
So you'd say for this one that we would be like around here to like here.
More or less. Yeah. And again, it's a judgment call.
There to there.
It's, yeah. And in this case, and David pointed this out, but the one on the right, clearly longer than the one, at least if I'm looking at it correctly, than the one on the left. The Mallar space is longer. And what the statistic that's always used is, width, is it half as long, is it twice as long, is it three? So it tends to be a judgment call to some extent where those lateral margins are, and you just have to kind of feel your way. I mean, I don't know how you handle that, but
it depends on the group. So like in Calides and Bombus, it's a relationship to the width of the mandible. Andrena, we're not talking that great of a range of Mallar spaces. So largely the mandible edge is just your stop, and we compare it to the rim of the eye, like how many rim lengths as the measurement point rather than the mandible.
Katerina says to look at the hinges. You can unmute if you want to expand on that.
the hinges of the mandible.
I think so, like David's doing here.
Yeah.
So a good paper to look at is Joan Malam and Johnson's paper on bumblebee Mallar length, which came out maybe 3 years ago or so, and they were Denny Johnson is an engineer, and he has all these super precise tools, and he had to, he was just going to go there, and so they very carefully and precisely talked about measurement points. And you have actually two condyles on the far side. Those are like the things that curve in and grab into the structure of the integument. And then you have an offset lump in the middle. And this gets very confusing because no one tells you these things. That offset lump is muscle, and it's pulling on the rim of the mandible to open and close it. But when you're looking at it, it's like, where exactly am I measuring? To the outside of the condyles, to the lump, to the condyle? Anyway, they did a very good job, and it turned out once they defined it precisely and measured it precisely, almost every species of bumblebee was separable by, not just like statistically, but actually by that ratio. It was pretty incredible. So here, I think the problem is just not that much. The malar length is just not that great. So here we use in the Discover Life one the widths of the eye rim as something convenient.
So in the top right image, would the width of the light orange area considered as the malar space width? So are we going from, I think this is what you're asking, from here all the way over? Is that your question? Or does it stop here where the orange stops? Is that what you're asking?
Yeah, Claire, I'm asking about the width, not the length of the malar space, but then between the eye and the mandible, there is that, yeah, where you're pointing at, because it looks like David's, there's that line above the image says clockwise increasing malar space, which means this one probably has the shortest malar space. And they just always confuse me because would that light orange area be considered a malar space, or so all the kind of reddish orange below that, that's not part of the malar space? Is that correct?
Well, I'll mention that this, from my point of view, these are kind of confusing pictures. So the bottom two are clear. That's what when I see a malar space, I'm looking at the dark, I'm pointing, but you can't see it, the dark strip between the eye and the mandible, and that's pretty clear. The upper two are a little fuzzy in terms of, I normally don't see that configuration, and I'm not sure even, like, I normally don't see that much of that amber color, that brown amber color there. So I would have a hard time myself defining in the first two the malar space from the pictures. Now, if I had the specimen, I'm going to be rocking it back and forth and looking, and maybe the first one clockwise, so upper left corner, you don't really see any black integument at all. In other words, the amber just goes right up there and kisses it. So I think that's why it's considered to be 0. But the picture is not what I would have in my mind for that. And then the second one, so this would be to the left, so the upper right corner, you can see there is a little tiny black strip there, but it is a little tricky to see, and the eye rim is a little obscured. And then the next two are very clear to me, so I can see the eye rim very clearly in both, and that's my measurement tool, and I can see the malar space very dark and black. Everything's black clearly. So I'm going to say that, well, that's my interpretation of that string, and I'm having a little bit of difficulty in the first two in the top row, but I think if I had it in my hand, it would be less of a problem. That's the problem with pictures.
I agree with you, Sam. I would mess with those pictures.
All right, sounds good. Thank you, Sam.
Okay. Yeah, well, here you have 3 people who have been spending a whole bunch of time on Andrena, and you know, just showing you that how subtle these things are. And so, like, if you come to a character like this in Discover Life, you would just maybe skip it, or you would score it for a number of things or something. But in a dichotomous key, you know, you have to pay more close attention or start following multiple lines. So it works both ways. Dichotomous keys are simpler in a lot of ways because you have fewer options. We are guiding you down this path, and we have decided this is your best path. And it's something like a matrix key, like Discover Life and others, like, hey, you figure out the path, buddy, and you know, you wander off it at your own risk. So you have more chances to mess up in some ways. But both are difficult for slightly different reasons, and that's why you want both around.
The last thing I'll say about this key and most keys is that the numbers in parentheses. So you're a couplet 6, and then in parentheses is couplet 5, is number 5. That's the way to tell where you came from. So if you get to couplet 6 and there in parentheses there's a numeral 5, that means I came from couplet 5 and I can back up. So it's a way to backtrack. It sometimes be very helpful.
Yeah, this is really useful when you get way down the key, because Mike is going 1, 2, 3, 4, 5, knocking out a bunch of things that are pretty unique, you know, that are one-offs, and then later it'll start spreading out. And a lot of times as you become more skilled, what you'll do with these keys is you go like, I think it's this species, and then you find it in the key, and then you work your way backwards. And or you're saying it's either this or this. Where are they sitting in that key? And by working backwards, you can find the split between the two. And very rarely these days, but sadly still occurring, sometimes they don't give you that, you know, the parenthetical backspace number or whatever it's called.
I'm gonna wrap us up. That was a good like reminder of how I like to work with keys. I'm gonna send out. Yeah, I have the Mallory space paper. It should be already on the Microsoft team. So if you're not just joining this chat, you're also you're in the Microsoft team. It's under files and papers. But I'll also send it out in an email response to everyone. And it looks like we'll pick up here where we left off next week for the next, I think probably all of 2023 is going to be Andrena now.
It could be.
Well, we could. I think
you guys asked
to try and get some Westerners involved in some of these things, and I would learn a lot from that.
Yeah.
Can I make?
I mean, David, you are a Westerner.
Yeah, for now.
the one on the screen. And Mike, what's up?
I'm having trouble typing. This keyboard has a lot of sticky keys that I'm using, so I can't type this comment. But if instead of the 2 arrows for the Mallar's face or the 2 lines, if we had a complete box, the parallelogram showing all 4 edges that you're counting, it would be much easier.
Got it. Yeah.
Let's try it.
It's probably worth having an entire document for each of these characters. Here's a Mallar space document. Here's 50 different species Mallar spaces. Here's a, you know, corbicula. Here's a prenodal ridge thing. Yeah.
Well,
and
and Sam, to follow on what you were saying about the Bombus Mallar spaces, is every time I look carefully at these things, I believe that any little piece of a bee would be sufficient to nail it if you were the true expert. So getting really into the weeds on any one of these small characters is super useful. So I may do the 50 Mallar space spread.
There you go.
Do it.
We'll see.
My last thing before I stop our recording. So where did it go? Is this key for males? Wait, hold on. Where did it go? Is the key for males available?
No, because you can't read my sloppy writing. I haven't typed it all in yet.
How dare you? You're only doing all of the keys for us. Okay, well, that's it for today's recording. You guys can keep hanging out. yeah, and we'll pick up after Miserabilis next time.
Okay.
Cool.
Hey, Sam, I want to mention I was